Hi. I'm going to tell you a story of something that happened to me and how I solved it and how you can solve the same exact very specific problem yourself. Let's say you went on Facebook Marketplace and you found the Black & Decker Pivot Plus. Measure, drill, drive. What a wonderful, fantastic invention. Oh boy. Ignore this part. Ignore this part. Let's say you found the Black & Decker Pivot Plus. Free on Facebook Marketplace. It can't get better than that. No charger. Well, that's fine. It has a DC. Okay, you can look at this a little. It has a DC barrel plug. All I need to do is see what voltage it needs and plug in one of the chargers of my bin of cables that I hoard forever, and I can use it, and that's wonderful. So let's take a look. The Black & Decker Pivot Plus Measure Drill Drive, trademark. See what voltage it takes. 6 volts, and that's a little DC logo right there. All I need is a 6-volt power brick. So let's take a look at what we have. No. Close. No.
What?
No. Why do I have this? No. So yeah, you look through the bin, and I don't have a 6-volt power brick. Imagine a world so simple as if I could just connect 6 volts to these 2 wires. I could charge this drill and use it to my heart's content. Oh boy, what a feeling. Typically, you just go on Slamazon or AliExpress or eBay or whatever the hell you want and buy a variable bench power supply with a little knob and some alligator clips, and you can make 6 volts and connect it, and boom, Bob is your uncle now. Well, I think $30, $40, $50 is too much for me to get a bench power supply. I don't like it. I just need it for my Black & Decker Pivot Plus Measure Drill Drive with measuring tape. Integrated. Just gotta flex that. So what do I do instead? I make this. Oh boy, what is this? Horrors beyond my imagination. You got it, buddy. Essentially what I did is take this buck converter and cram it in this 3D printed case, which I've melted the edges to keep it contained. Let's go ahead and undo my hard work. Oh, that'll do. Ignore these. So basically what these little boards do is they take in a DC power and they give you these 2 little teeny tiny knobs which suck to use and give you an output. I've gone ahead and wired a USB-C little board here. Oh, I'm no expert on wireless charging, but something here isn't right. Wonderful. Imagine a world where you can just put some DC in here and turn this little knob with your flathead screwdriver and change your output voltage. Wow. I decided to do something else. I've decided to make something, and this video will serve as a way that you, yes you, my beautiful audience member, can make one yourself. Give it back! And you're going to make something a little prettier than this. This is kind of garbage. Instead, this is what I've created. There's scratches on the screen. This is what you'll be able to make yourself with no scratches on the screen. 3D printed. It's a little box. It has a nice, beautiful buck converter with a easy-to-use knob, 2 banana plug voltage outputs, or you can, screw a wire in there if you really care to. Some specs on the side, some cooling vents. There's an optional fan in the back. There is a technically optional output fuse and a USB-C input. USB-C input. But that's what I plug in my phone with. How does that work? Well, let's take a look at this wiring diagram. I definitely didn't make this in MS Paint, and I only have a black and white printer, so you can't see the red or the black wires. It's quite elementary, my dear Watson or whatever. This buck boost converter can take in whatever DC voltage-ish and put out whatever DC voltage-ish. 5 to 30 volts in, 0.5 to 30 volts out. So you can give it 20, I guess, and turn this little knob and then get 9 or 6 or whatever you want. So how do we get some power? USB-C. And the cable has a whole bunch of pins, and they all do a whole bunch of stuff. And this is the USB-C power protocol of how it sends data across the cable to negotiate. And I don't understand how any of this works because you don't need to. Essentially, when you plug in your charger to something, The something will talk to the charger and say, hey, I can take 12 volts to charge this device. I can take 20 volts to charge this device. Let's go ahead and grab something that can mimic that signal. Here is the 20 volt trigger module. Essentially what this is it's a USB-C port, and there's some smartness in here, and it will tell any charger, I can take up to 20 volts. So let's take a nice high-powered USB-C charger. You plug it in, they do its talking, and now on these two pins we should have 20 volts. Wow, what a world we live in, huh? So now that all the thinking is done, you might be able to see where this is going. Let's take that 20 volts and let's shove it into this thing. And then you can give the user a nice little knob, and then they have these terminals that they can attach wires to and get whatever voltage they want. But what if they touch the wires together? Well, let's add a fuse in there, so in case you touch the wires together, it's not going to explode everything. It'll just pop this little easily replaceable fuse like this. So I created this monstrosity, and it was wonderful, but as soon as you drew too much power, it would start to overheat, and it would shut off for overheat protection. So I added the fan in the back of the unit. How do you power a fan? Someone could plug in a 20 volt charger, someone could plug in a 9 volt charger, they could plug in the cable from their car and get 5 volts into this. How do you power a 5 volt fan proper? Let's get a voltage regulator in this circuit. Voltage regulator can take in between 4 and 30 volts, which is within the USB-C range we're going to deal with, and it will always output 3.3 or 5 volts or whatever voltage output you buy a regulator for. It regulates the in voltage to always be constant. Take a voltage regulator, connect it to the power input. It will always output 3.3 volts, and that can power your fan. Boom. Bob is your aunt now. You have a benchtop power supply. And this is what we're going to make today. So now begins the actual tutorial of how to make this. This wiring diagram is available alongside the download files on MakerWorld and Thingiverse. Here's your parts list. There's also a text or Excel file. I haven't decided yet of all the parts you need to get. This is the Buck Boost ZK4K. This is a 20 volt USB-C decoy module, little 3.3 volt regulator. You need 8 screws, 6 32 by 3/8 inch. To be safe, I recommend your 7 wires be 18 gauge or larger. So 18, 16, 14 gauge will all do. And then you'll need your output terminals, a positive and a negative. These come in packs and they're not that expensive. There is a fuse and a fuse holder, which you can put in there. There is the little fan. These are commonly known as Pi fans for Raspberry Pis. They take 5 volts in, but we're going to only give it 3.3. If you're a fan of abstinence or an abstinence of fans, you don't actually need the voltage regulator and fan to make this work. In that case, you're going to get about 10 watts continuous, 25 watts peak before it starts to overheat pretty quick. With a fan, you can get 20 or 30 watts continuous and then the full 50 watts peak without much worry of overheating. So I recommend it, but you really don't need it. As for the 3D print STL files, they are on that MakerWorld page and Thingiverse. There is a main housing, which is this big outer part, and there is a back shell. There's also a form of the back shell for passive cooling in case you don't put the fan and voltage regulator in. You just have some big air holes, and there you go. Bob is your nephew. So let's go ahead and get wiring, shall we? Let's make some connections. I'm going to start with the front of the circuit, that USB-C power trigger module. There's many models out there. This particular one on the bottom, it has labeled out plus, out minus. So out minus is on the side towards me. Put on our flux. And a puck screw. So the 20 volt trigger module wired up, and I have some leads coming off of it. Optionally, you can do 2, one for the fan circuit, one for the buck boost converter. We're not going to connect it to these buck boost terminals. It actually has to go into the main housing before you can connect these wires. Let's start on the second half of the circuit. There are many other terminals out there you can use, but these ones in particular come with this little ring, half of a Steam logo. It's Steam. The larger side of this ring goes in the screw hole, and the smaller side we can actually connect our wires to it, so let's go ahead and do that. If you didn't want to add that little fuse in there, you could end up connecting these directly to the output of the buck boost. I'm going to go ahead and add a fuse for this one. The way that these are wired up is they have this terminal which will take these mini fuses. When a fuse is in, it bridges the connection between these 2 pins and these 2 pins. The simple point of this is now if we connect these 2 prongs to our buck boost converter and you're using your voltage out of here, if you accidentally connect these 2, power is going to go through the fuse first for safety. So instead of shorting and exploding, although this does have a shorting protection built in, this is an added layer of safety, your fuse can protect your circuit. If you're not adding a fan, this is all the soldering you have to do. Just your USB-C port input and only 1 pair of wires. And your output leads, simple enough, but I'm going to add the fan real quick. This 4R7 voltage regulator on the bottom has its labeling. There's an in and an out, a positive and a minus. Wow, that's a secure connection. Now I will solder them. And now my out, our 5-volt fan. Let's go ahead and circumcise it. Get our wire strippers up in here. I'm going to tin our wires, tin the pads of my voltage regulator output. The fan's pretty simple. The red is the positive, the black is the negative. If you are wiring up a fan, you can actually test this out at this point. Make sure that the extra wires that go to the buck boost converter are not touching. And if you'd like to, you can plug in your USB-C regulator board. Just make sure nothing's touching anything, because you could get angry. Wow. We have spinny. This is a 5-volt fan, and you can use a 5-volt 4R7 regulator if you'd like to. The 3.3 volt is fine, it just barely gets the spinning. It's quite silent, and that little bit of airflow is typically enough to keep these cool. So our soldering is complete. These 2 leads will go to the in section of our buck boost. These 2 leads will go out of the out section of our buck boost, and then our terminals will go on the end of each of these cables. I'll go ahead and clean up this space, get some 3D printed housing parts, and we'll do the assembly. Things are cleaned up. Our parts are 3D printed. There's 2 parts to this. There's a main housing, and there's a backing. There's 2 different backing files if you're going to 3D print this yourself. There's the one with a fan grill. Ooh, ah. And there's the one that's meant to be passively cooled. Ooh, ah. For this build, we're going to do the fan grill one. If you're doing the passively cooled one, you just won't have the fan and the 3.3 volt regulator circuit there. Otherwise, these are basically the same. The parts here, this is for the USB-C input. There's a USB-C input shaped hole on the back for it. It's going to slide right in there. This is a retainer clip for the fuse. Trust me, this little bulge is necessary. This is, of course, the fan grill, and if you are very, very smart, you can guess that these right here are screw holes. And this little groove spot right here is to help you professionally secure your regulator. Let's go ahead and get our professionally secure tool heating up for us now. To assemble our desktop power supply, we're actually going to start with the backing. A USB-C power board is going to insert into this quote-unquote slot like so. It's going to be a little bit of a snug fit, not super tight, but just like snug enough to hold it in place. And you're going to want to make sure it's pushed up as far forward as it can go. The USB-C port should slightly extrude past the back of the print. Let me push a little. There we go. A little click in place. It's extruding a little bit. It's designed not to be flush. It extrudes slightly, so any USB-C cable should work. It should not have any clearance issues. And use our professional electronic security device. So you start with the wires, because I don't want them to be flopping around and touching something they shouldn't. And with that cool down a little, I'm also going to add a little bit of hot glue to the sides here, and a little bit through this top channel. And let's go to the fan and the regulator board. So the regulator is going to sit, let's see, something like so. Now I'm no expert. That's not going anywhere. And then our fan. We'd like our cooling air to blow into the heatsink, not suck away from the heatsink. It blows air in the direction towards the fan hub. So the fan hub is going to face inside, and the fan blades are going to face outside. Put it where the wires are comfortable. You don't want your wires to be uncomfortable. They will complain and leave a bad review. While I designed this fan to secure with 4 screws, you really don't need it. If you use 2, I'm not going to call the cops. No one's going to know. Now that everything is professionally secured, you want to plug in your USB-C cable. Make sure your wires aren't touching anything. Your fan should spin up. Things are going nicely. For the main housing, the first thing you actually want to put in are your red and black terminals. I prefer red on the right, black on the left. Holding that red terminal in place, you see that screw post in there, or I'm going to take my fused positive and put that ring on it. And now there's going to be a little nut that screws on. And what I recommend doing is taking some needle nose pliers. This is not necessary, just really recommended. Take some needle nose, hold that in place, and give it a couple, like a half turn of snugness. We'll keep it nice and good. With these specific terminals, there's also a washer that comes in place. I recommend keeping that on because if you have the part, use it. If you don't have the part, don't worry about it. Nothing's going to catch on fire, probably. That's not guaranteed, not legal advice. Let's put that ring around. Let's put that nut on. And we're good. That's my front terminals wired up. So you should have a positive and negative, and they're connected to these wires. So if you imagine how we connect this to the negative output and the positive output, we have power. But wait, there needs to be a fuse here. So in this main housing, the fuse connector, the fuse housing, the fuse holder, the thing that holds the fuse slides in place like so. It's not too snug. The only thing we're missing is the big kahuna, our actual buck boost converter. Take note of the wiring here. Looking at it top down on the far right side, out minus and then out plus, in minus, in plus. So this will just slide into place from the front here. This is upside down. I'm a professional. And here's the fun part. Wiring. Out minus, out plus, in minus, in plus. These are our output wires. In my case, my green wire is going to the fuse block, which is my positive. My yellow is going to my negative. I need this to go in. And while holding it there, give this a little tighten. When you're really trying to crank down on this, the buck boost converter is going to try and pop out the front. So I'm going to hold it in place with my fingers while I tighten. And now the out positive, which is this fused cable in my case. While holding it in place, let's give that screw a little tighten. As for the input, in minus and then in plus, this is when our two halves will meet. My in minus is my brown wire, my in plus is my red wire. I'm going to go ahead and start with my in minus, that's next in my row, and make sure it's really tight. And same thing for the positive, in positive on the far left. Screw it down until it's snug. Give that a visual inspection. Nothing is touching. Everything is screwed into a spot. That should be all complete. And go ahead and put this backing onto the case. That's where it's all going to be. And 4 more screws. With our 4 screws tightened, everything is just about finished. It's not straight up and down flat. It's more of a parallel with the bottom face. That looks about good. Yeah, there we go. And now we can give it a test. Go ahead and plug in our USB-C cable here. Alongside the files to make this project, there is information about how to use this whole screen and this knob and everything you need. The terminals that I use for this project are to take in banana plug jacks. Very standard. If you have anything like alligator clips or spring-loaded clips, banana plugs are a common connector for the end of those. Connect in your negative, connect in your positive, set your voltage to whatever you want your voltage to be. If you're making this yourself, I hope that this guide helped you. I hope that you love the product. I hope you have a wonderful day. Any questions, just let me know. And you have a good one. It is days later, by the way. I almost forgot about this. But here we are. Let's charge our Black & Decker Pivot Plus measure drill drive. Yippee! Buy a power supply at my Etsy store.